Perfect. So we will speak in this presentation about new and novel method for transmission line monitoring, and it is based on optical fibers. My name is Eran Inbar. I'm the CEO of Prisma Photonics, and we will speak about the cooperation of Prisma Photonics and the Israeli Electric Corporation. So this cooperation between the two companies started in 2020. The Israeli Electric Corporation was looking to cover aspects of safety, quality, and commercial needs. And Prisma Power is our solution for transmission line monitoring that can bring all those use cases in a single solution. We started back in 2018 by initial proof of concept, and it led to a joint project that started in 2020. In this project, we cover two transmission line segments. The overall coverage was more than 100 kilometers. Most of it was overhead transmission line. Part of it was also underground transmission line. I would say that due to the positive results of this pilot, it was shifted from a pilot into commercial agreement over the term of this project. And now we're looking to cover more use cases and additional line coverage. I think that this quote that I'm presenting from Amir Livneh, Senior VP at the Israeli Electric Corporation, is summarizing the enthusiasm and the importance of this solution of transmission line monitoring into the IEC. Just to give a background, the Israeli Electric Corporation is dealing with generation, transmission, transformation, distribution, and supply of electricity over the whole state of Israel. A brief about us, Prisma Photonics. So our sole and exclusive task is to help our customers, the utility, to keep the most critical large-scale infrastructure up and running. We basically enable our customer to take responsibility on their asset in a real-time and actionable insight. The company was founded in 2017 and dealing, as I mentioned, with long critical infrastructure monitoring. In order to understand our solution, maybe the best would be to start with a single example. And I would like to tell you the story of this specific tower. This tower is in California. This is part of the backbone of the transmission line in California. And if I'm taking you back to November 2018, there was a failure in this specific tower. This failure was not, a catastrophic issue to the grid. So it doesn't shut down the grid, but this failure generated a side effect, a wildfire. And both of them, the failure itself and the wildfire, was not detected by the Californian utility because, as for today, there is no sufficient solution for transmission line monitoring. The consequences of this small failure was catastrophic. Quite soon after, it evolved into the deadliest wildfire in California ever. And we're speaking about 85 people that died. We're speaking about tens of billions of dollars of damages and eventually even bankruptcy of the Californian utility. And this is exactly what Prisma Power is all about. We enable the utility to detect in real-time failure and get the exact location of the failure. It allows the utility to detect wildfire, but it's also offer much more. Basically, you can cover almost any kind of environmental crisis, from fire to lightning strike to extreme wind to icing. It covers aspect of vandalism. It also aspect of pinpointing failure in a real time. But even more important, it giving a lot of insight about predictive and preventive maintenance. So you will know the exact location that problems start to evolve, and you can be very efficient with your maintenance actions. So how it's done? So all the use cases that I mentioned, from fire to lightning strike to failure to vandalism, you can think about sensors that can detect it and solve it. And you can think about installing sensors on the towers. But now think about utility that have thousands of kilometers. Now we're speaking about huge amount of sensor, and this is an enormous cost and complexity, both for installation and maintenance and future upgrade, and very fast it become completely not cost effective. And our solution, we call it sensor free because we don't need to install any sensor on the grid itself and nothing on the towers. So how we can sense something without sensor? The idea is that the sensor was already deployed for us. It's not called sensor. The utility called them the fiber optics cable, the OPGW cable. Those pre-existing fibers can be used as our sensors. And therefore, the installation is very simple. When we are plugging our system into this pre-existing fiber optic network, a single system can turn 100 kilometers of fiber into high precision sensor. So basically, just by placing a system in a pre-existing communication room in a substation and plugging it into the fiber, that's the whole installation needed. And once you're doing it, 100 kilometers of the fiber is being covered. And if you have thousands of kilometers, the only installation needed is a system every 100 kilometers or a dual system every 200 kilometers. That's it. And as you can guess, it has an unparalleled return of investment because there is no need to install anything on the grid itself. And also the deployment is very fast. We're speaking about deployment of hours instead of deployment of weeks or maybe months. And the cost per impact and the cost per kilometer is unparalleled. And it's important to say that even if you have thousands of kilometers and you have multiple systems, eventually all the information is presented in a single and consolidated user interface in the customer command control room. So the customer has a single screen. He can see the whole network, the whole transmission line, even if it's thousands of kilometers. And on the transmission line, he can see any event in real time and see the classification of the event. Is it a failure? Is it aspect of vandalism? Is it a wildfire? Is it a lightning strike? So all of them presented in a very simple graphical way. Let's speak about the cooperation with the Israel Electric Corporation and speak about the use cases that were tested and demonstrated over this mutual cooperation. And let's start with the first use case. It's security aspect, and this is aspect of vandalism. So we tested and tried to detect alert for security events. We tested events like damages to the tower, hammering the tower, hitting the tower, sawing, which usually related to metal stealing, and even tower climbing. And all those events were detected in real time in an accurate tower location. So it's not that we give an indication that somewhere along the network there is an event, but we can say the specific number of tower that right now in real time there is event on. So the action the action by the utility, it's quite simple because you have in real time detection, classification, and precise localization. Another use case was a maintenance aspect, and we're speaking about short circuit localization. We place the system and we wait over a long time for an event of short circuit, and luckily this event happened. And when it happens, we can immediately detect it and indicate the specific tower that the short circuit happened on. So that allow a very precise predictive maintenance, because now the utility know the precise location of the problem, so we can come and investigate the specific tower. And in this case, it was tested by the IEC, and there was a correlation with, first of all, with the fault recorder that in the same time that we find the short circuit, the fault recorder indicated there is a problem there is a short circuit along the grid. And also the root cause of this problem can be found and treated. Another use cases is predictive maintenance, and here we're speaking about the corona or the partial discharge status of the grid itself. So what we are doing is basically measuring the corona or the partial discharge level on each tower and tower. And we're giving to each tower what we called a corona score. So this score is in correlation to the level of partial discharge or corona effect on the tower. And when it passed the threshold, we can give an alert indicating the towers that the level of the corona scoring is higher than the required threshold. What was very interesting was the fact that we find out that those readouts are not stable over the day. So from day to night and night to day, you see a fluctuation in the corona scoring. So it gives us the indication that if you're trying to find them using a camera or a point detector and you come into a specific tower and measuring in a specific time, maybe you will find it, maybe not. But in our method, in which we are covering 24/7, 100% coverage of the grid, we can measure it and find the trend in each tower and tower, and therefore we can get the indication, even if it's fluctuating, we can still find and locate the problematic towers. And when we got this event, we can give a precise indication on a user interface, so the Israel Electric company can see it on the user interface, and it's quite simple and intuitive. What will be the forward direction of our cooperation, Prisma Photonics, with the Israeli Electric Corporation? So first of all, right now we are in the process of extending the transmission line coverage, adding more and more segment, and increasing the scope of this mutual project. And the next and very exciting step is to integrate this solution with the IEC SCADA system. So now you can get a fusion of the information on the grid, and you can get alerts correlated to other events. We are very happy to join the Israeli Electric Corporation in their innovation journey toward a reliable and high quality and safer grid. And we would like to thank our partner at the Israeli Electric Corporation for the opportunity and looking forward to build a strong relationship.